with the leaf symptoms, probably the most distinctive one is that upward cupping of the leaf. And it can be accompanied by some interveinal chlorosis and maybe some reddening, but the upward cupping of the leaf is probably with some colour discoloration is particularly early on in the crop is probably what's going to give it away. But be careful, because I suppose there are herbicide damage and those sort of things that are very mild, can look the same, and it can be misdiagnosed. Next one, thanks, John. As far as some of the trigger values for analytical side of things, the NutriPack manual would say that once we get down to below 0.5 milligrams per kilogram on the DTPA extraction method, and just be careful, I've mentioned DTPA, that's not the same as EDTA, then we're looking at our potential for some zinc deficiency problems in the crop. But also we need to take into account some of the things that vary the sensitivity around that, and that's soil P. The higher the soil P is, the more likely you are to get a response at a lower zinc level. Root growth rate, and that relates to cold soil temperatures around planting, or anything that restricts the root growth rate, a bit of herbicide damage, or those sort of things can throw you into having some zinc problems early at around or below that critical level. The higher the soil pH, particularly once it gets above 8 and gets towards 9, that can influence this as well. If you've got a soil that's high in calcium carbonate, that can increase things. Waterlogging can increase the sensitivity around that value. And fallow length and rotation crops. So the whole VAM story, whether you've got mycorrhiza to help you out early or not. Now, what all that does, given that that's not built into that single value, tells you that there is a lot of variability around whether you get a response based on a soil test to zinc or not, or whether you can predict a response from a soil test. And I would say probably not with any degree of certainty, but if you add up all of those factors, it gives you a risk profile. So if I've got a low value, high soil P, cold start to the season with a bit of herbicide damage, high pH soil, and coming in after a longer fallow or a rotation with someone might have grown some canola in dryland situations, look out, you could have a zinc problem. Really the only way to be sure is to tissue test, because it integrates all those factors together. The plant actually tells you what the combination of all those factors are, and by and large that YMLB B4FF is youngest mature blade before first flowers. So once we start dropping below 20 milligrams per kilogram in the plant, start to suspect there is some effect of a lack of zinc on plant performance. Thanks, John. Just to confirm, what we're saying about this, I've done some surveys of plant tissues that have come out of cotton that we've conducted through our company, and this is the 2012-13 season. I haven't added the last couple of years in yet, but just looking at the frequency compared to the lines on the graph are actually the critical levels from a literature review I did, and Nutrologic, what it's actually saying about the critical levels. And it just shows you the proportion of plants sampled at those times that fell above or below what we would say is a critical level. So by and large, for those seasons, and most of this data in those seasons came from the Central Valley, so from the Macquarie through to the McIntyre, you would see that a lot of the soils there are supplying sufficient zinc according to what the plant is responding at various times across the season. Yes, there are some that are below the line, and they may be, the crops are probably at risk. But given the long zinc history that a lot of the crops have had with the introduction of compounded MAP and zinc products, that's not a surprising result. But if we extended that out into some of the other areas, that may change. But it would say there that there is the opportunity for zinc problems there. Okay, copper. There's an old Cyocra small leaf type variety of cotton, a selection, if you believe that. Probably not, but it is not cotton. In fact, you probably, for those of you that have been around a bit, probably know what it is. Up in the top left corner. The fact that I can't find in cotton a photograph of copper deficiency in cotton probably tells you how, anywhere in the world at the moment, tells you how common it is. So copper deficiency is not common in cotton on the soils that we grow it on, and there is no record of copper deficiency in cotton in the research literature as well as anecdotally at this stage, but we can always be shown up. So, the thing to be on the lookout for is possibly copper deficiency in rotational crops, where we have some sort of idea of what it might look like. And the one that's most sensitive is actually wheat. Is a species that is very sensitive to copper deficiency. So, but it looks very much like frost. So we've got to be very careful that we don't confuse frost with copper deficiency as well. So next one, please, John. So again, soil testing, very crude discriminator about where we probably should be for looking a bit more closely at copper. Notionally, a level below about 0.3 milligrams per kilogram on a DTPA test probably bears a bit more investigation, and that investigation would probably be, once again, a plant tissue test. And if it was to come back at less than about 3 milligrams per kilogram, you may have some further investigations with maybe a foliar spray or something like that. Wheat is probably where we have our best information, and the sort of critical levels in wheat are about 1.8 milligrams per kilogram. So possibly we just don't have enough calibration data on copper to actually know where it occurs. I've put in here once again a survey of the data from there, and you can see there's a few dots in here falling down into where for Nutrologic, what this is the typical range of nutrient that's found. It sits nicely in the middle of all of those dots. Recent some literature stuff that I've done in other dicotyledon, it would say less than 3. We know in Australia it's less than 2. I suspect the fact that we haven't seen symptoms that more so than that there is copper deficiency around, that our critical levels are wrong at this stage, and it probably should be more that down at 2 rather than 3. So we haven't seen it. We don't see very low levels. Mostly they're up pretty high. So copper deficiency is one that I don't lose sleep at night over during the season. Next one, John. Just throw us into some of the things that push along copper deficiency and zinc deficiency is tillage, or the lack of tillage tends to increase the frequency of the deficiency, because zinc, being immobile, relies on a lot of root contact, and the more volume of the soil that we've got with contact with zinc and copper, the better chance we have of taking it up. If we've got less tillage, we're concentrating or stratifying these nutrients in the surface, and therefore we're probably in some ways sending ourselves more towards a zinc deficiency as we don't cultivate. As I said, high phosphorus, phosphorus 1, it inhibits mycorrhiza when it gets really high, and if we don't add zinc at the same level as phosphorus availability, we can have the mycorrhiza suppressed by the high phosphorus and run into zinc problems because there's no mycorrhiza to help uptake. Any root pruning and restrictions, higher yields give it higher demands. The use of imported fertilisers with high NP and low in zinc. So classically, once we changed in the mid-90s from locally produced MAP, DAP from rock sources in the Pacific Islands to Duchess, and overseas we run into low cadmium but also low zinc. So we're not getting the inadvertent addition of zinc from the ammonium phosphates that we got in the early days, and that does predispose us to being careful. So next one. The other things that that increase the frequency is in some cases we're going on to less fertile land from a zinc point of view. You know, we've got in those southern areas, we've got acidity, we've got canola production, we've got liming. Liming increasing the pH can reduce your availability of zinc, and as I said, canola prior to excuse me, cotton can increase your sensitivity to mycorrhizal problems. And I would suggest that probably also it's part of the syndrome of cotton following rice in those southern valleys, where you get a lot of waterlogging over the rice production period that has an effect on the mycorrhiza, possibly the chemistry of zinc in the soil as well. Exposure of alkaline subsoils through erosion and land levelling, those areas that are cut higher in pH, sodic and lower in zinc and copper can expose you to having isolated patches of zinc deficiency through the crop. New cultivars and species, so you know we don't know what's coming through, but sometimes it is possible for new cultivars or new varietal releases to be more susceptible than another. We do know that in wheat, but we don't have much idea in other crops. More clean fallowing from the mycorrhizal point of view, and more non-VAM rotational crops do increase our sensitivity. So that's the zinc and copper side of things. Coming to those that are probably, you know, iron, as we're showing there, is probably more frequent than copper deficiency, but it comes and goes, it's transitory, and it's generally on the back of waterlogging. A change in the ionic state of iron under waterlogging, a reduction, reduces the availability, and we can end up in some cases with iron deficiency showing in the crop for a period of time while the iron is in that reduced state from waterlogging. And generally that happens, you know, for a week or two, and you'll end up with these yellow patches. It's not necessarily everyone, and it's not the whole crop, and it can be isolated plants. We see it in sorghum as well, and if it does go on for long enough, then it is worth spraying. But generally, it's a leaf or two from a transitory waterlogging event, and you end up with this bright yellow coloration at the top of the plant. And that's fairly typical of it. So once again, it's like iron deficiency, I think, is universally seen as being something that is very hard to diagnose with either soil or plant tissue concentrations. Now we have levels there, but it's very variable. The reason why in plant tissue we don't have a lot of confidence in the current tests that are available that iron occurs in both 2+ and 3+ states in the plant, only one of which, the 2+, is available to the crop and useful for photosynthesis. So if we're testing total iron in the plant, it's testing the total concentration of 2+ and 3+, and it's not telling us about whether there's more reduced iron there, in which case we're going to have iron there, but it's not actually contributing to photosynthesis. So I suppose really the only thing we can depend on is the symptoms. The test in the plant to do active iron is not necessarily conducted in the labs at this stage. We don't have enough of it to really justify it. And again, looking at the plant tissue data, we do have an outlier down here for some reason. I'm not sure what it is. but by and large, very rarely. We get a few that dip down into the low levels. You might be concerned, and that might be crops that have just been irrigated, and a tissue test was around at a time when it was still waterlogged from irrigation. But by and large, the numbers are well above the critical value, so iron is not necessarily short supplied. Next one, thanks, John. Manganese, another trace element that is, suspect. Both iron and manganese deficiencies have shown up in mung beans, in particularly two varieties, crystal and jade. So they have shown right across areas from St George to Emerald to the Central Darling Downs. There have been incidences of manganese and or iron deficiency in mung beans. That's basically on the back of there's two varieties there that appear to have that genetic sensitivity to those. But manganese deficiency can be quite commonly mistaken for zinc deficiency. The symptoms can look the same, particularly the coloration, but manganese doesn't come with the cupping of the leaf by and large. So that's one of the ways around it. Again, the soil test, given we haven't seen much manganese deficiency around, we're usually working on international standards more so than locally calibrated numbers. And once again, the soil test is subject to a whole raft of things like zinc around soil conditions, weather conditions, as to whether that the less than 2 value is accurate. Once again, the plant tissue test isn't too bad as a starting point to understand whether you've got low manganese in the plant. As I said, we haven't seen a lot of it in cotton, but we certainly are seeing it in mung beans, and the question is it just a matter of time before we get a variety that comes out that is more susceptible? So once again, the plant tissue levels that we're getting would suggest that that we're by and large we're quite a way above what we would say is as critical in the plant. So manganese tends to be one of the last ones I go to with copper. I think you'll probably see zinc and iron problems before you'll see copper and manganese. Next one. So the problem with zinc, iron and manganese is generally not the amount that's in the soil, it's poor availability. They're very, very much subject to changing conditions around waterlogging, pH, which will convert it quickly to unavailable forms, but equally quickly they'll convert back. So once the conditions that cause the conversion go away, they frequently come back fairly quickly, and the plant will have a leaf or two that's affected, and then it'll grow on normally. Generally with these two, it's because the soil is so subject to changes, it's generally best to foliar apply them, and multiple sprays might be required. Because if you put it in the soil, it'll get converted to unavailable forms fairly quickly as well. As far as chelates and soil application, we've got to be careful in the high pH soils that it's not the normal cheap EDTA chelate. If you're going to try and put it in the soil, then you've got to go to a more complex and more costly EDDHA chelate, which is more stable under alkaline soil conditions. So if you're mixing it into a brew with as a starter, then you're going to just need to be very careful which chelate you might use. And waterlogging generally leads to iron deficiency and sometimes even to manganese toxicity. Boron is I suppose commonly a nutrient that's talked about with cotton, because cotton is quite sensitive to boron deficiency. And down in the bottom right side there, you see the effect on bolls, those water-soaked black spots, and the leaf tip the terminal of the plant not expanding properly. There's a range of symptoms, but it just indicates boron is generally not translocatable within the plant, so it's going to happen if there's going to be a problem at the top of the crop. Next one, please. But remembering boron in soils is subject to leaching, so it's mobile. Organic matter is frequently a good source of it, so if we've got deficiencies can limit seed production. Toxicity is easily induced, so we've got a very narrow with boron tolerance to over application. It shouldn't be band applied because whatever you put in that band, whether that be seed or fertilizer, will likely be excluded from getting at it because of the toxicity chance of boron in a band. So you usually apply it in small annual doses or as a foliar. Next one, please. So the trigger values for cotton is about 0.4 milligrams per kilogram. High pHs do reduce the availability of boron because of the tie-up with calcium in high pH soils. And with pH greater than 5, we've got to be careful. The toxicity level is about greater than 5 in subsoils. So it is quite possible to have a toxicity, a deficiency, a deficient layer overlying a toxic layer. Once again, because it is mobile, it's a bit like nitrogen. You've either got to know what's in the subsoil or wait till the plant has reached, water extraction has reached at least 60 centimetres, and then plant tissue if you suspect boron deficiency. Then we would say the youngest mixed planted blade, less than 30, would indicate the possibility of a deficiency. Once again, so a plot, you know, really what this is saying is generally the cotton industry for the area, there's samples, as I said, this is from the Macquarie through to the McIntyre. We haven't had a lot of instances of boron deficiency. And, you know, a lot of surface soils come back low in boron, but as I've said, they generally pick it up later when the root system gets down into the subsoils that are quite rich in boron. So by and large, we don't see many boron problems, even though cotton is noted as being one of the more susceptible species that's grown with cucurbits and brassicas. Molybdenum, I put this one in, if it had been a few years ago when before our southern cotton cousins joined the fray, then I would have not probably put molybdenum in because by and large there was no cotton grown on acid soils. But there are some cotton starting to be grown on acid soils, so molybdenum, the chance of molybdenum deficiency does increase a little bit, seeing we have some of those southern cotton soils that are acid. So when we're looking at molybdenum, next one please, again we don't have many examples of molybdenum deficiency symptoms, but canola, if it's showing in canola, if you're growing that in rotation with cotton, then you'd have to have a look at cotton being another species. As far as trigger values in soil, we don't have any. Excuse me. It is possible to soil test for molybdenum, and some labs do offer a calcium chloride extraction for molybdenum. But as far as I'm concerned, in my experience, and that coming from some sage knowledge in soil testing, would say that the variability in the lab is about the same as the critical level. We're talking about very, very light concentrations. It is so you really can't discriminate between the lab error and and the value that you might get back from a lab. So really we go back again to plant tissue levels to evaluate the tissue. If we're looking to try and discriminate whether we've got some problems in that area. So, John, I've lost for some reason. Okay, thanks a lot. When we're talking about application strategies, generally talking about possibly three as far as methods: broadcast, banded, and foliar. By and large, broadcast has gone out of favour because of the upfront cost and the rates that need to be applied, but and the requirement for mixing into the soil under zero tillage. But certainly where people are getting into cut and fill areas, where you're actually disturbing the soil, doing reforming of slopes and that sort of stuff, if you've got low zinc areas, then broadcast and incorporating as you bed up is probably a very valid way to go, patching out the micronutrient rather than trying to band it through the whole the banding with phosphates. The other way is the liquids in starter fertilisers, quite a valid way of applying trace elements, as in foliar application. Because they're used in such small amounts, we're talking about tens of grams of uptake per hectare is all that's required. Then we can get it in through the leaf, it's you've got multiple strategies for application, but just be careful around the soil application ones that in year one they may not work as well as after multiple years of application. So sometimes in year one, I would suggest, even though you've banded it into the soil, that maybe a foliar application or even a seed treatment might be something to back up that broadcast or banded, because the plant is just so reliant on roots finding nutrients. The nutrients do not; these trace elements do not flow from the soil to the roots. Next one, please, John. The other one that I'd suggest that you look at is the solubility. If you're looking for a response in the year of application, then the solubility of the trace element in the fertiliser, the water solubility in the fertiliser, is something that that regulates response. And this is just some trial data from corn in the US, but it just shows you that the amount of nutrient you require to get a response or to change the soil DTPA level depended very heavily on the solubility of the zinc, or in this case zinc, coming out of the combined fertiliser, the compounded fertiliser. Next one, please, John. And the same goes with this, the percent water solubility. So to get 90% of corn, maximum corn growth, that's the 90%. Of 100% water soluble, it took 5 kilograms. To get 90% of a 70% soluble product, it took double what it took. This is in year one, and year two is different. And if we get down to a product that's only 30% water soluble, we're talking about 4 times the rate of zinc to try and get the same performance out of the crop. So solubility, if you're looking for response in year one, it's important. In year two, year three, not so important. They tend to equalise out after year two, year three from continuous application. Next one, thanks, John. Foliar sprays. Just remember, we're talking about immobile trace elements in an indeterminate crop. In other words, we've got not being transferred between plant parts, and we're getting yields set all the time. I think we go back to the early spray programs based on on what we understand about the right thing for wheat and sorghum and these more determinate crops. I question whether if you've got zinc problems that spraying certainly well into the flowering period could be a good idea, rather than just an early spray in that reproductive stage. And there's so many foliar sprays on the market. I just say follow the supplier's guidelines to reduce risk of foliar damage, because that is the risk with foliar sprays. You're putting on an important part of the plant at a time when it can't afford to lose leaf area generally. So the risk is from burn more so than from ineffectiveness of the product. So, just to sum up and allow you to ask a few questions, trace elements are essential for efficient production and utilisation of the other nutrients that we generally put on at higher amounts. If they're left untreated, they can have large effects on yields and efficiency. Plant tissue analysis is generally more accurate predictor of crop performance than soil analysis. It only takes small quantities of uptake to satisfy the crop requirement, and there are a range of application strategies available, and they relate to just when you become aware of there's a likely problem in the crop.
That's great, thank you, Chris. I'm just working through now questions. Can manganese be toxic, and at what levels? Asked by Kieran. Chris, do you want to have a go at that?
Yeah, manganese can be toxic. Generally, we find it in acid soils. It's unlikely to be toxic in a alkaline soil, and it's generally after a waterlogging event. We get a large burst of availability in a young plant that's stranded and maybe in an acid topsoil. So we see it just about every season in canola in the south. There'll be soils that have lower pH, reasonably high manganese levels in them, and we'll go through a waterlogging event. Coming out of that, we'll end up with a burst of manganese availability, and the crop will show symptoms. So possibly a problem if we had cotton growing on acid soils with seedlings, because generally in the south, those acid soils, they increase with pH with depth. So it'll be in that seedling stage if we had a problem.
Okay, thanks, Chris. I'll just unmute everyone. So if anyone would like to ask Chris a question, please feel free to do so, but just mute yourself if you don't think you'll answer a question, or else we'll get 12 lots of background noise. So does anyone have any questions for Chris? No at this stage?
No, fine. You there, Chris?
Yes.
Yeah, Chris, I've been doing some soil tests 30 to 60 centimetres. With regard to zinc, I've been getting levels, DTPA levels of 0.27 milligrams per kilogram. Is that any concern, and yeah, can I do anything about it anyway?
The 30 to 60 layer will generally be lower than the 0 to 30. So look, it is a combination of the two. There is some work going on in that dryland stuff with the deep placed P to have a look at zinc, but we don't have any relationships we can rely on at the moment. It's more the case that where people have put on phosphorus deep and overcome a phosphorus problem in the plant, they've induced a zinc problem with the extra growth and the extra P concentration in the plant. So the idea is to place zinc down in there deep in the soil with the phosphorus, so when the roots are accessing the phosphorus, they're accessing zinc. Now that work's currently underway at the moment, assessing it, so probably a little bit early to say. We can say for phosphorus what we understand are the critical levels in that 30 to 60 layer or 10 to 30 layer, but we probably don't have a lot of information about how much zinc you require in that layer. I would say in irrigated crops it's probably not as relevant as it would be in dryland cotton, because we are getting re-access to those surface high concentrations in the top 30 centimetres in irrigated cotton once every irrigation cycle. So we're getting a gut full of trace element as long as we've got reasonable concentrations in the top 30 centimetres.
Okay, thanks.
Does anyone else have any questions? Thanks, Wayne.
Well, I'll just make a comment, John. At some stage in probably the next couple of months, I'll update all of those graphs around the cotton levels we've found in the plant. And obviously, in the last couple of seasons, when I put the dots on there, they'll probably mostly represent samples that have been conducted in the far-flung regions that are still growing cotton. So we're probably more a dominance of southern New South Wales and probably the Darling River area and further afield. So it'll be interesting to see how they sit versus those central valleys from years when they dominated the amount of cotton.
Okay, all right, great. Well, thank you, Chris.
I'll make the offer there. If people are interested in seeing that stuff, well, yeah, give us a contact me, and I'll and when I do the analysis, I can send it out.
Sure, thank you. Well, look, if there's no other questions, thanks again, Chris, for taking the time out to present this information and collate the information and to be available for questions. And the slides and the recorded webinar will be made available on the CottonInfo website. So thanks again, and signing off, Chris. Thank you, and thank you all for logging in.